All right, good morning. Week and a half left. We left off with this idea of redundancy. And redundancy means we have multiple components. So in the case of things like a hard drive, which is probably the most common thing to fail, and it's kind of an odd thing. In the data centers and in your servers, you still often use spinning drives. For our home computers, we've all replaced them with solid-state drives. But in some cases, the spinning drives are much larger. So I can get a 14 gigabyte or terabyte drive. I can't do that in solid state. So for a lot of large data installations, it's much cheaper to use spinning drives. They fail. So do solid state drives, quite honestly. And actually, we saw in this lab a couple of years ago, we replaced 32 computers. We replaced all the drives with flash drives, solid state drives, and nearly every one of them has failed at this point 3 years out. The original hard drives from 2011 in most cases are still functioning, which is kind of an interesting mix. But what we know is the more items we have, so the more cars we have, the more likely it is that one of them is going to fail to start. The more hard drives we have, and so in even a moderately sized company, you could have hundreds of hard drives. We realize that we're going to get some failures in there. And so we know that those things are going to fail. How do I mitigate that damage? So, mean time between failure is an important number. We're not going to go into all the statistical calculations of how you would do some of this because I don't want to drive everybody completely insane. But one of the most important things actually is how long before you can repair it and get something back up and running. So that mean time to repair, I think, is actually a better number that we need to worry about. And how long you can afford to be down. So at Peru State College, if our website is down for a couple of hours, probably nobody is going to have a major heart attack. It's an inconvenience, but we're not losing millions of dollars in sales. If Nike Shoes website is down for a couple of hours, it's probably a much bigger inconvenience. On the other hand, if Blackboard is down on a Sunday night when most classes end, that's a major inconvenience for a lot of students and faculty. So we have to weigh those costs. And so the way we fix almost everything is duplication or redundancy. And it costs. So we have to weigh what our costs are versus what the costs of not having redundancy. And so we looked at this diagram with multiple connectivity to the internet, and that's most organizations that are, anytime you're above a few employees, you probably should think about this idea. Especially down here, for example, in southeast Nebraska, if you're relying on Spectrum for your internet service, you should know it's single-ended. It isn't on a loop. It feeds out of Lincoln down to this area, and if it gets cut by a backhoe in Lincoln, right outside of Lincoln, the entire corner of the state loses internet service. Well, if your business depends on that, I hope you have a backup plan for internet service. So you really need to look at that very carefully. And most larger businesses, you will have redundant connections of some sort, and you'll create a plan to allow you to utilize those. And how we do things. Losing it through Spectrum. So I just picked on Spectrum because Spectrum has one cable that comes out. There is no loop back up into the city of Lincoln to where it feeds out of. Correct. So a lot of times you get two vendors. So if I'm down here and I'm running the hospital, I have probably contracted with, in the case of, say, Auburn, where your two choices for the most part are Windstream and Spectrum, I've probably purchased internet service from both of them. And then I've got either a router that can handle those and a switch over, or multiple routers. And so depending on how I can configure that, I will have multiple vendors in there. So if I'm in Lincoln, I have a lot more vendor choices So I might have Allo and I might have Windstream or something. So I tend to always have a failover. One of the most costly, but it is effective down here if we need it and we don't lose service a lot, is actually there are ones that are cellular. So yes, it's expensive to get my data from a cellular network, but if I have to keep my business open, that's one way we can do it. And so there are actually routers that have a SIM card and an antenna built in, and you can actually then get service from Verizon. And depending on the cost, it can be reasonable or it can be expensive. It depends on where you're at. The one thing I will say that Verizon has done that's really kind of interesting in that is if you're a non-commercial entity, you're a governmental agency particularly, you can actually get a reasonable unlimited, and I use the air quotes because it is limited, but and it's only like $50 a month, so it's not a horrible cost to have on there. Now, if you start downloading 100 gigabytes of data in that month, they're probably going to hammer you into the ground. But as a quick failover, it's an effective way, and it's limited in speed. It's not nearly as fast, but we've implemented that in a couple of locations where we're working with. I do some work with some police agencies, some policing type agencies, where that's our failover so that we can still get internet through for things like the ticketing systems and other things. So not probably the most efficient way, but it still keeps that system up and running. So part of that is how we fail over that device. So in the case of the systems I've set up, that router that's also got a SIM card and it will fail over automatically, it essentially sends a heartbeat signal out on the main connection, and when that connection fails, within about 30 seconds, it's firing up the other connection and switching data over. Now, it doesn't work perfectly, and I will say that because we have some hard assigned IP addresses, so we have to go a little around the corner, but it's about 90% effective. It keeps the core business operations open on those. So we can have an automatic failover. So in other words, we have redundant parts. So whether it's a spare fiber, whether it's a spare network driver, power supply, fans, and servers tend to have a lot of these in redundant pieces. So the more money we spend on a server, obviously we get a little more redundancy, but depending on what level of server, you have redundant network cards, you have redundant fans, you have redundant memory in some cases, so it's got a couple of extra sticks of memory. Certainly hard drives, and we're going to talk specifically about those in a second, but those will fail over automatically. So as soon as it detects an issue, spins over to the replacement device. Hot swappable, so one of the differences between a server level machine or an industrial commercial level router and those kinds of ideas is they have the ability to swap parts in while the machine is running. So things like hard drives, I can swap them while the machine is running. If I do that on my home computer, it hiccups and goes, oh, nope, not going to work. So oftentimes we have inside of our drive array, for example, we have a hot spare. So it's sitting in there, already installed in the device, but we have allocated it as a spare. And so if we have a hard drive issue, it automatically pulls that one in and uses it. The other option is we have cold spares. So we have parts that are ready to swap in. So some installations we've gone as far as we have a spare switch. We have a spare component for everything so that in the case something breaks, it's going to take us a few minutes or a couple of hours, but we're able to put those pieces back in. And one of the things I will say about Corona has made it very difficult to get certain components. A lot of factories are shut down, have shifted manufacturing. So it's made it more apparent that in some cases we really needed to have that idea of having those spare parts and those spare pieces. And when you're on a bare budget, like a lot of businesses are, it's hard to convince them, hey, you should probably have a spare router sitting here in case this one dies. Because even if you buy a component that's in warranty and it takes you 2 or 3 days to get it replaced, you could have some potential issues there. So it's something to think about in your business, thinking about how I deal with that. So one of the best things we do on the network side is we do something called a lag group, or a link aggregation. So we have multiple network interfaces, and we combine them to one. So we may have 4 network interfaces on a server. That's pretty common to have at least that many. And we trunk them all together. And so all 4 of those interfaces are connected to the switch, and the switch and the computer all think it's one connection. So what it does, if one cable gets cut or breaks or something weird happens, the other 3 are still able to carry that communication signal. So it does a couple of things. I get more output because I know that I have, instead of 1 gigabit links, I now have 4 1 gigabit links. It gives me that failover piece, and we can balance that traffic out a little bit over multiple links. So this is just an example of what that would look like. So switch to switch in this case. So instead of just 1 uplink cable, we have 3. Most switches, so we're in this case, are able to do probably 4 groups. It depends on the switches, how they can function, but this gives you that redundancy. So if somebody accidentally unplugs something or bumps a cable and knocks it loose, now instead of 2 links or 3, you might be down to 1. But it's still better than having that link completely broken. So this is the other advantage to that, is in this case, because I have multiple network cards in that server going to the switch, because it doesn't combine them in the sense that it becomes one big giant pipe, but it distributes that traffic over those lines, so that in this example, what you're seeing is each computer or workstation is communicating with a different network interface card in there. And so we can improve that throughput very, very rapidly by doing this. So that gives us some redundancy. And in this case, because we've already bought that equipment, it doesn't really cost anything. It takes some setup time. So what I was actually doing last night from 7 to about 10 o'clock was actually setting up some link aggregation groups and reinstalling some switches for a business client that I have. And that's what I was actually doing, was set up some redundancy so that instead of a single point of failure, we were trying to avoid those kinds of issues. And that was set off by another technician that wandered in there for another company, and they managed to pull a fiber loose. Well, that fiber was the connection between the switch and the servers and the rest of the outside world. So it presented a kind of an issue. So now we have multiple fibers running so that it will, and they're in a link aggregated group, so that now instead of 1 10 gig per second connection, there's actually 4. And if one of those gets disconnected, the other 3 will still maintain communication. So how we set it up, so of course, it seems like everything we do, we have to have a new language or protocol for it. And we certainly do with link aggregation. There's another protocol. This is what allows us to use those links between different vendors, for example. So I can aggregate 4 links between a Linksys switch and a Cisco or an HP switch or something else. So typically you have some options in there. So they're showing a TP-Link switch, which is not typically a high-end. But here they're aggregating a couple of LAN links, 3 and 4 in this case. And we typically have some different types of modes we can use. So we can set them up statically. Now, depending on the configuration and the vendor, static has a little bit of an issue. It doesn't allow for that failover if one connection drops. It can actually be a liability there. Typically, we use kind of an active mode. So in other words, those 2 switches are communicating with each other, and they can actually assign those and assign the routing dynamically. And so the switches do a form of something called load balancing. But a lot of times we actually bring in a special device just for load balancing. It's essentially a form of a router, if you want to think about it that way. and it allows us to distribute traffic among multiple computers in and outbound. So one use for it is things like a server farm. So if I'm Facebook, I know that one server is not going to be able to handle everybody trying to log into Facebook. So what we do is we create an address, and that address can go to any one of these servers that are behind there. So let me show you the example, maybe makes a little more sense. So here's Facebook, and here's all their web servers. That load balancer sees that traffic coming in, and it splits that traffic to all of these different, and it could be hundreds of web servers, and that load balancer distributes it. So from the outside world, we see one address. From inside, so it used kind of a virtual address from that load server, and that load server will send it out to the appropriate switches and the servers. So it distributes that load amongst all the devices. So this is even a place like Peru, where we're serving up a web page, could actually have something in this like a load balancer and multiple web servers that are out there. That way you have that redundancy. So if server 1 happens to go down or it's overloaded, that second server can be assigned those tasks and can pick up that load. So load balancers are kind of an important item in our list of fun things. We know that the virtual machines are now taking over most server clusters. So we have distributed switching. So in other words, that switching can work between multiple virtual machines. So in this case, we have 3 virtual machines on host 1, 3 virtual machines on host 2, and that switch works between those 2 hosts. So that virtual machine doesn't care whether it's on host 1 or host 2. We can move it from location to location. It's going to function the same. So there's some terms out here. The most common one is something called vMotion with VMware. But that's that ability that even though that switch isn't native to just one of these computers, we can move those items around. And so it's part of what we also call a software-defined network or software-defined switch that we can do that. So that's a little outside of the scope of most smaller companies. But you'd be amazed out here who's using that kind of technology. So hospitals like Auburn, even as small as they are using virtual images in their servers. Certainly we're using them here at the college. So they're out there. Well, there's other things we need to worry about. So we've built redundant components, and now we need to think about a backup plan. Because even though we've got redundant components, things can happen. So one of them that can happen is simply an employee doing something like, hey, I'm going to delete these files. I think they're just mine, and I delete them. Oh no. So our backup, part of what we have to do is think about what we need to back up. What is it going to cost us to back up? What is the cost to not back up that data? So we're going to have to pick the appropriate software. We're going to have to pick the appropriate location for backups. Are we backing up to tape, which is still a valid means? Are we backing up to a hard drive array? Are we backing up to somebody else's server, aka the cloud? Are we using multiple methods? And hopefully you are, because there's advantages and disadvantages to each one of these models. How much manual or personal time are you using to have to do those? And I will tell you, the worst thing you can do is require a backup that has to have somebody intervene every time, because guess what? It doesn't happen. People forget. People go, oh, I should have hit the backup button, but let me go do that Monday then. Well, then if you have a server crash over the weekend, hey, all your data is gone. Now we worry about things like ransomware. So is your data protected that's backed up from getting ransomware and encrypted on it. So there's a lot of pieces to this, and I'll kind of give you my take on what might be a great model. So storage medium, what are we going to back up to? Well, hard drives at rest. In other words, there are levels of hard drives you can buy. So for a server, you buy a drive that's ready to run 24 hours a day, 7 days a week. But if I'm doing it to a data backup, hard drives that are sitting there without spinning are pretty cheap. And they're pretty reliable. So if you can afford it, I like a backup to drive. It's a little quicker, and it allows me to grab data wherever it lands. I also know that a lot of organizations, that's not feasible due to the size of their data. And so tape backups are appropriate. And so there are, one of the most common ones I use is actually a tape backup system that holds 8 drives inside of it, or 8 tapes, and it auto-loads in the correct drive. And it'll store about 100 terabytes of data. So it stores a huge chunk of data, but the problem with tape backups is you have to screen through the whole thing. It's like the old VCRs, if you remember those, where you have to scroll forward to the point you are. You don't have any way to jump to it directly. The other medium that a lot of people look at is the idea of backing up to the cloud. And so the cloud has some disadvantages and some advantages. The best advantage it has, it gets that data out of your data closet, out of your building, off-site somewhere else. So what are the disadvantages? It's slower because it's depending on your speed that you have of internet service to be able to push that data up. More importantly, getting that data back. If you have terabytes upon terabytes of data, getting that data back from a cloud-based service can take a significant amount of time. Days and weeks in some cases it can take. Just because of the size of the pipe that you have coming in, it's going to take that long to pull that much data. No, you're pulling all of your data back, and it can take a significant amount of time. The one thing that some companies do, and again, you're paying more for this service, but if you have a data incident, they will overnight you a hard drive or hard drives that contain all of your data, and you can pull your data from them. But again, you're paying depending on that amount of size, how secure that data is. You need to make sure that that data is encrypted, not just from you to the backup company, but it's encrypted while it's at rest, and transport and at rest so that nobody else can get a hold of that data. If you have data that's critical for your business and you ship it off to some company and they go out of business, what happens to that data? So we need to make sure that you have that data is secure. So the last piece is making sure those backups are secure. Now, hopefully, even if you're using tape or a local drives, you're encrypting them. Once you have that data all encrypted, I need to store it off-site. So storing it then in a bank vault or something once a month is not a bad plan. The problem is, what about that person taking that drive to the bank vault? They stop, they have it in their car, and somebody grabs that car and breaks into it, or steals a car, or just reaches in the door and grabs that suitcase that it's in. Now you've lost every piece of data for your company. Unless it's encrypted, and encrypted well, you could possibly lose data. So it's tough to make these decisions. So generally what I do is I actually like 3 copies of data. So what I really like to do is back up to something like a hard drive array so that I have a very local, very fast backup. I do more of an archival system, something like a tape backup also, preferably if the business has multiple locations, so it's in a different location from the original. So that way if this building were to burn down, my data is actually stored somewhere else. And then finally, I do a cloud backup. So I have 3 different sets of data that I can access. The other key with this data backups are making sure that you actually can get the data back. Try it. Verify that you can get your data back. So you've created a plan. Generally, so our book talks about there's the father-son or the grandfather-father-son plans and things. How we back up our data is pretty important. Creating that plan, making sure it's done, making sure that it's checked and corrected. If I can't pull that data back, all that expense and time and effort doesn't mean anything. But there's some examples of companies that have pulled back their data pretty quickly. So Lincoln Public Schools a couple years ago was a great example. They had a disgruntled employee that burned their office building down. Lincoln Public Schools central office burned to the ground. They were able to get their data back and up and running within about a week. So there are examples of how we can pull that data pretty quickly. So there are different types of backups. So this to me has always been a little confusing when I'm trying to explain it. So a full backup makes sense. A full backup says, I'm going to take everything and I'm going to back it up. All right, that makes sense. So I've got the backup until today at 5 o'clock. Everything's backed up, all my data. That's going to take a lot of time and a lot of storage space to back that up. So generally we do full backups monthly, maybe weekly. Sometimes we do it depending on the organization. And then we have to figure out how we're going to back up the rest of that data, because we know from Monday to Friday that data is going to change. So we have our base set, that full set of data from Monday. So incremental backup then says, all right, Monday, I'm going to back up everything that's changed since that backup was done on Monday, the full backup. Tuesday, I'm going to grab everything from Tuesday and Monday and back that up. And then I'm going to grab everything Wednesday through, and so every day, that incremental backup gets bigger and bigger. But you have essentially 2 files when you need to get. So you have to have the original and the latest incremental backup for it to work. Great. But again, that penalty is every day that backup gets bigger and bigger and bigger. Differential backup says I'm only going to back up what's different. And so Monday, we have a full backup. Tuesday, I see what's different, I back that up. Wednesday, I see what's different than Tuesday, and I back that up. Our servers crash on Friday. Now I need that full backup, and I need the differential backup for Monday, for Tuesday, for Wednesday, for Thursday. So depending on your schedule and your sizes, they're both effective strategies. But the incremental is going to take a little more data, but it requires less files. And so we have to think about the reliability of that data and how sure we are that we can get that data back. So part of this is that regular schedule. If we're using virtual machines, there's some other backup software that allows us to even take snapshots exactly of that data. So this is kind of that design of that incremental and differential, showing you what's different in there. So incrementals, we have all these little pieces. Differential means only what's different. So different types of data. Creating that plan takes a little effort. Implementing it takes some effort. Selling it to your boss that, hey, this data is really critical, especially if they've not had a data loss before, is a hard sell. But you have to look at it in terms of what happens if we didn't have our server. It was just gone. What would happen to your company? What would happen to that data? Here's all our customer data. Here's our sales data. And it's gone. How valuable is that? So how we store that data. So we have to have some kind of a backup, but there's a little bit of confusion about how we actually store data on our network, how it works. Because we do have some redundancy, but it's not redundancy that we're going to use as a backup. So think about when we start talking about these hard drive solutions as, hey, yes, my data may be safe, but what if I got compromised with a virus? It's also compromised with a virus. So we're going to talk about some of these network storage technologies. So the first term we're going to talk about is something called a NAS, or a network attached storage device. So if I'm a small business, I can buy something like a Synology, and I can get one for $500, $600, a couple $100 in drives, and I'm up and running. So that NAS can sit out there and work as a shared file storage for me. I can back up local computers to it, and hopefully if I'm using something like that, that NAS gets backed up somewhere in our plant. So these can be fairly inexpensive. They can store a lot of data. So I really like the Synology stuff, quite frankly, I will tell you that. And if I'm a small business, I'm probably going to buy one. It's a great place, so all my employees are storing their data on the Synology box. Synology actually has a replication tool that I can buy another Synology device, and I can set it at a remote location. So my brother-in-law is an architect out in Colorado, and so his office downtown, all of the architects and designers and everything store everything in a Synology device. And then at his house, he actually has a Synology box that replicates it. So there's quite a bit of distance between each other. And I think after we talked, they actually put it in one of the other partners, so there's actually 2 copies of data, just in case. They had some of the fires, and they got fairly close to his house, so there's a couple of layers of space in there. So that drive, so you're typically a NAS drive or a NAS box has multiple drives in it. So it probably makes sense to look at what one looks like. So that's a very typical type of a NAS box. So in this case, it's got 4 hard drives in it. Those hard drives have to be some way combined if we're going to use them all in one pool. You could use them individually, but that's typically pretty cumbersome. You want to have a lot of storage in one drive or for it to show up. And so there's a couple of different ways we can do that. So RAID, or Redundant Array of Inexpensive Devices, was developed so that we can put data on multiple drives, and to you, it looks like a single drive. So RAID has some different types. So there's RAID 0. So data is written across multiple disks. RAID 0 is a speed increase because one of our limits in our systems is how fast we can read and write data. So RAID 0 can help us in speed because, hey, now we're spreading data over multiple drives. The problem is RAID 0 also tells us we don't have any redundancy at all. So if we're spinning it out to 2 drives and one of the drives fails, we lose our entire system. It's gone. All your data is gone. RAID 1 says everything on drive 0 and drive 1, they're mirrored completely. So the drives are completely duplicated. So it's our most expensive technology because to get the space of 1 hard drive, you actually have to have 2. But it gives you a lot of advantages in terms of if one drive fails, that other drive is mirrored, takes the data, you won't even notice it. There'll be a blinking light on your server or your NAS box. And then we have a couple of others. There's other levels. So RAID 5 is kind of where it starts to get interesting. So RAID 5 says we're going to take 3 drives, and we're going to take a little piece of each drive and share it on the other drives. And so we call that parity information. So if one drive dies, we can replace it and rebuild that data. So every drive is stored on its original drive and stored across the other drives in there. So if you lose essentially one drive worth of data. So if I had 4 gigabit drives or terabyte drives, I could have 3 terabytes of storage. So RAID 5 is kind of where we started. RAID 10 is where we want to be at in most cases. So there's some other variations, but RAID 10 says, well, not only are we going to put that parity information, we mirror it across to multiple drives, so it takes a little more drive space away, but it's much more robust. So in this example, if we had 4 terabyte drives and we used RAID 5 in this box, so most of your Synologies, these style of boxes will run RAID 5 pretty easily. So I have 4 terabyte drives, so 4 terabytes of storage space, but because of the way I combined them, I have 3 terabytes of storage space available. So maybe this makes a little more sense. So RAID 0 means we read and write data across both drives. So there's no advantage of data stored 2 places, but I get an advantage of I can read and write more data quicker because it's just distributed across multiple locations. RAID 1, that idea of mirrored, means that they're identical. I have 2 completely identical drives. And then RAID 5, or any of these multiple selections, so part of this drive is stored here and here. Part of this drive is stored here and here. This drive is stored there and there. So if a drive fails, I can replace that drive with a new one, and it will rebuild that array. But that takes some time and CPU cycles to do that, because it's got to go out and get all the information from these 2 drives to build up that 3rd drive, or 4th drive, or 5th, however many we have in there. So there's advantages to both of these. This takes away less drive space. RAID 1 is the most transparent, most expensive, but it might be our best option for certain sets of data. So here's what I have done on quite a few servers, is the operating system is up on 2 drives here. And so that's pretty common. We mirror the operating system. So Windows Server 2016, 2019, 2049, whatever's out there, we mirror that on 2 drives. And because that operating system is fairly small, typically we actually are now using solid-state drives or SSDs for that. So we have a pair of fairly small drives here. That's got our operating system. And then our data is stored on a separate array of drives. And so we may have 12 or 15 or 30 drives in here, and we use either RAID 5, RAID 6, or RAID 10 to store that data. So here's our example of RAID 10. So RAID 1 just says, hey, I'm going to mirror these 2 drives. RAID 10 mirrors the drives and then stores parity between them. So it loses a little bit of storage, but it gives you 2 sets of parity bits instead of just 1. So I can pull out, in some cases, a couple of drives can fail at the same time in a RAID 10, and I'm still able to recreate that data. So a NAS typically uses this strategy for data. Our servers use this strategy for data. So a NAS can be very inexpensive, or it can be hundreds of thousands of dollars, depending on your storage size. But typically a small business, you can put a NAS in place easily for $1,000. It'll store enough data for a smaller business. It hangs on the network. Everybody can get access to it. The difference with a SAN, that storage attached network, so these devices typically are in the server closet only, and they have some additional fault tolerance pieces, and they typically are connected only to your servers. So if I have a network like this, so here's my Ethernet LAN over here on the left. So my network attached storage box would be available anywhere on there. And it would set out here. My SAN actually sets here, and it's connected directly to the server. So here's different types of file servers. It's connected directly to those servers, and we use a couple of different models. So there's fiber channel over Ethernet, which is pretty popular at this point. The one I've used the most is something called iSCSI. There's InfinityBand. There's a lot of different technologies. So it's a separate switch. It is not your Ethernet switch. It is a separate switch. These are typically much faster than our Ethernet switches. And they're connected directly. And they're typically multiple connections. So if you notice, we use multiple switches, multiple connections. So it's highly redundant, highly resilient, and very, very fast. Well, the push for this really comes out of we're doing all these virtual machines. Those virtual machines, so I may have 10 servers on each one of these as virtual machines. I need to send data in and out of them very quickly. And I typically don't store the operating systems even and the data on those servers. They're stored on that SAN. And they're stored on that SAN, so if I move that virtual machine from one server to another, it's available anywhere. So SANs are really what has allowed us to do these virtual machines, very scalable in terms of size for data centers. So they have a high fault tolerance. They can have they can have petabytes of storage available if you're willing to pay for them. So huge amounts of data, virtual machines, high fault tolerance, not cheap. So I've been working for a little bit with a friend of mine who's an IT director at a hospital, and they just put in a SAN to support their system. That SAN is a little over $500,000. So it's a lot of money. It's a lot of storage, but it's also a lot of money. But it's very fast. In this case, at that hospital, they have anywhere between 100 and 400 virtual servers running at any time. And so they have an entire server farm of servers that run virtual machines. And so they can move that data back and forth. The data for all of that is stored in that SAN. It's not cheap. They've got a lot of money invested in that, but you have to, unfortunately. And that hospital is still doing okay. They're able to live with COVID and other issues. But that's how they're able to maintain, in some cases, 400 connections to that sandbox. If I put it on the LAN, so it was just a NAS, it wouldn't have enough ability to pull that data quick enough. So it's much, much, much faster in a scale of probably 1,000 compared to a NAS box. From the typical workstation, you don't see that SAN. They do have a NAS or two in there where you can store data, but that's not where all the server stuff is stored. And that server stuff is all tucked on that SAN. So there's a big difference between them. They each have their purposes. Typically, a small business, you're going to start with a NAS. You start moving into virtual machines. You'll probably build a SAN at some point. Probably the cheapest SAN system I've built has been about 20 grand. So it's not unaffordable for a business of 50 to 100 people, but it does have some cost. All of that said, if I don't back up that data, all that redundancy to protect me from a drive failure means nothing. So be aware of that. So one of the things we also have to worry about is power. And for those of you that live here in Peru or been here, our power in this place is pretty crappy. We lose power fairly regularly. how do I deal with that with my server, my computers, my items? So a couple of things that happen in there. So we can have a complete blackout. Power is completely cut off. Well, that's catastrophic, but it doesn't typically cause as much damage as some of these other things. So a surge, in other words, when I get a very large power spike, so lightning, maybe they have an issue with a transformer, that can damage equipment. If you have a lightning strike by your house, all your electronic devices can get damaged. So that's very damaging, and we try to protect against that. Noise. So all these devices on our electrical grid cause noise, and at some points it can get so bad that it interrupts our ability to process data. What's almost most damaging, though, is something called a brownout. And if you lived in California, you would remember that brownouts are when, hey, we don't have enough voltage. So what happens in a voltage loss, so instead of having 120 volts or 240, that voltage drops to 80 volts or lower. And what happens, your computer is still trying to run, those servers are still trying to run, but they are pulling more and more current. So if you go back to Ohm's law and your physics classes, the amount of power they need, it depends on the voltage and the amperage. So the more amperage we pull, it's going to make the wires hotter in there, and at some points it's actually burning out items because of that voltage sag. Brownouts are actually pretty damaging, and we have them a lot. So in our lab in here, if you notice in the middle of every desk, we actually have a battery backup device, not because I want to make sure the computer lab can run if the power goes out. I'm less concerned about that. But these were designed to stop surges and also help us with the issue we have in here where the voltage would sag too low to be safe. And we lost a lot of computers trying to figure out what was going on in here. Even though they redid this computer lab a couple years ago in terms of power, we don't have enough electrical current in this building. And in fact, the server closet, what I discovered this year, was it was supposed to be on its own isolated 20 amp circuit or whatever we agreed on. Well, it's not. The server closet is actually shared with the wall outlets in Dr. Amber Mahan's office, and if she runs her coffee pot and I have all the servers on at the same time, it pops the breaker. So we have not yet come up with a complete solution for that. I was less than thrilled when I found that out. So they kind of cut some corners when they redid this building. When that's fairly typical. We have to worry about those. So we've had a lot of power issues here. So typically our first solution is much like we did on these desks. We put a UPS or uninterruptible power supply. So those battery, they have a battery in them that will run when the power goes off. There's two different types. And so these are what we call an online model. So they are always using the power from the wall to continually charge the battery. The battery then powers an inverter, which then powers the device. So they're on all the time. So that's our ability. So when the power drops low enough, these devices will actually boost the voltage from the battery back up to 120 volts and avoid damaging the computer. Now, it can only do that for a while, but it does it long enough we can notice and go, hey, let's shut everything down. A standby UPS is cheaper. And a standby UPS only kicks on when the power switches off. So when the power goes off, boom, it switches to the battery, hopefully quick enough you don't have any data loss. So in our server closet, we have a UPS also, and a much bigger one. It can actually run that server back there, if I'm only running one, can actually run it for about 3 hours. But if I have all of my equipment back there running, I have about 10 to 15 minutes. But it's also an online UPS. I can monitor the voltage and I can see what's going on. So the online ones are more expensive, but quite honestly, they're worth it. They give you that protection from brownouts and surges a little better than the online models. So these guys here on the desk were about $150 a piece. You can get one similar sized that is just the standby UPS for probably $50 or $60. So Well, those are pre-COVID prices. I haven't priced anything on those. So we need to figure out how much power we need. How long do we want to keep something running? Do we need to condition that line, which was the purpose of this? And then we need to test our equipment. Once we install it, pull the power. See, does it actually work? In the case of our server, typically we would actually have 2 UPSs with each power supply plugged into a separate one. If you have dual power supplies, you probably also should have redundant power circuits. Well, we certainly don't here, but an actual dedicated data closet, they would have multiple power lines going in. And those power lines, you would have one connection to your server on one circuit, the other one on a separate circuit. So even if that breaker blew, if that was actually designed as a server closet, so Amber Mahan kicked on her coffee because she needed coffee, and kicked the breaker off, that server would then go, oh, no, I'm going to use this power switch over here. So typically we have multiple lines running in. We also have the next step. So most organizations also have then a generator. So another term for your battery backup sometimes is called a ride-through. So that's a pretty common term I have heard. It's designed to be on long enough for the generator to power on, because the generator takes a couple of minutes to come online and provide power. So you need to make sure if you have a generator. So in the case of this lab, we don't. This lab is not powered by a generator. The administration building does have a backup generator that can be fired up, and it'll generally take a couple of minutes to get those powered on. So a couple of things on those. Make sure that you have fuel available, that it's good fuel. There's advantages to all different kinds of generating stations. So there's an advantage to propane instead of diesel. Diesel's probably easier to truck in. Propane is certainly a viable solution. That's what I see most of them around here. Sometimes I run it off natural gas. Well, that works great unless you have something like an earthquake and the natural gas pipelines get shut off, and then you have to deal with that. So what we also have are a lot of times are multi-fuel generators. In other words, they can run off natural gas, they can run off propane, they could run off diesel, and so we combine those depending on how long we anticipate that need's going to be. So all these things come together. One of the problems with any of these generators, backup, in most server rooms, the most power is not actually being used by the servers. It's being used to keep that room cool. And so you also need to make sure that if you have a long-term plan, you're going to have to run for hours or days, that you have a way to cool that server closet. Because if that HVAC equipment isn't included on that generator list, great, I have power to run everything, but it turns it into a pizza oven pretty quickly. So one of the more innovative systems I saw actually relied on compressed air. And so it would provide power for a while on compressed air. So it had some very large tanks stored in the ceiling. And while you had power, it would compress air and fill those tanks. When you lost power, it would use those to generate power. So it would turn a turbine. And one of the things, if you've ever taken a can of the dust off spray and you turn it upside down, it'll get super cold. The same thing, when you're using it as a generator, you're allowing that air to expand and it gets cool. So in that time, it actually cools your generator or your room also. So it's kind of an interesting model. They're not designed to run for hours, obviously. It's a ride through until that generator comes on. But it's kind of an interesting thing to look at. So there's our idea of that generator, and they can vary in size. So you can have a small one for a small business that's, the size of a doghouse. You may have ones the size of a train locomotive for other installations. So it depends on how much power you need to generate and keep running. And then generally you'll have circuits dedicated to the generator. So you're not going to typically power your entire organization off that generator. So if you look at most hospitals, as a good example, most hospitals have generators In fact, I don't know of any that don't. But you'll notice some of the outlets are typically red and some are white. So the red ones are typically the ones that are on that emergency generator. And so you can see very quickly which ones are going to power and stay powered on. You certainly don't want to turn off somebody's oxygen because you lost power for a couple of minutes. So you have these UPSs that provide power until that generator kicks on and comes online. Well, we have other things that can happen. So disasters can happen anywhere from a cyber breach to a hurricane to a tornado to a flood. Part of that idea is we know that these things could happen. We need to train and have some plans available for them. And so no matter what the disaster, we need to think about what's going to happen. So right now, and I think this is a little prophetic, now we're talking about a network infection of some sort, but think about COVID. Has that affected companies in terms of having staffing available? Sure, that needs a response. And so we typically have a policy we develop. So how do we follow these? Well, no matter what our business, we really probably need a plan to deal with issues. So preparation. What do we need to do? How do I detect that there's an issue? Contain the issue. Remediate, in other words, get back up and running as quick as possible and recover. And then at the end, I think it's the most important step. Reviewing what happened. Wow, everything worked except we lost a bunch of data because we lost some UPSs. So maybe we need to go back and go on a yearly check and see if those UPSs work. So we review and we make changes to our policy. Hey, everything worked really great. Our college didn't flood, but our sewage treatment plant and water plant are down in the flood zone. And we have remediation for it. So if you think about Peru's response to that flooding, well, now we got through it, we remediated, they put in a temporary water plant. Now they're looking at, it sounds like they've settled a deal and they're going to actually get water from Auburn now. So that's that recovery. And then when we review that process, you say, well, maybe we should have done something different in there. What else could we have done in those steps? So we definitely want those done beforehand. You want to look at what can happen. Oftentimes we throw people into roles. And so we certainly do that here if we have some kind of an incident. We know that some people are, for example, they're dispatching people around. You may have captains or assignments of you're in charge of this group, so managers. Typically you have some PR people, and so certainly we use our people over there if we have any kind of an incident. Certainly with COVID, you don't want every employee talking about this incident and trying to figure out what's going on. You do want to contain that a little bit. There are some, if you lose data because you have a data breach or you're infected, that communication should probably go through a chain of command. And much like, so UNMC, the medical center at Nebraska, had a serious data breach. Employees were asked not to speak about it because they didn't have the full details of what went on. And so they also need to contain that a little bit. So disaster recovery, we think about what those conditions are, getting back critical functions, so we need to prioritize which systems are more important than others. And we want to account for the worst case. So we had flooding and we had a tornado come through. How do we deal with those horrible situations? So there's a term called business continuity. In other words, being able to continue doing business. Well, we're doing that now. We're looking at business continuity. And the way we did it in the spring when COVID first emerged was we moved all of our classes online. That was our business continuity plan for the college. We said, well, all right, we don't know what's going on, but we know that it's not safe to gather in groups. Let's move everything online to figure out and how to continue our business model. And so we're looking at it now. I don't know what's going to happen in the spring. Hopefully there really is a vaccine that's going to be available. But we look at that goal of how do we continue our business operations. So restaurants, if you look at restaurants in this COVID, a lot of them have moved to takeout and delivery and other things. So it's that plan of how do I continue my operation. So disaster recovery plan should have people named, where everything is stored, how my data is stored. So they should be very detailed. What kind of, how the details on my network, the details on my computer systems. So how do I test those? Things like tabletop exercises where we get everybody together and talk about it. We also should probably plan some drills. So maybe you were involved in some drills with EMS and other services, the same kind of thing you need to do with that data in your IT department. So you may be required to turn those in to insurance companies. Some insurance companies have gotten very proactive into getting into recovery and data. So if you have a business policy that covers you for loss of revenue while you're down, they're going to want those things. They want a copy of your data plan. And whether they pay out or not may depend on if you follow that plan and if you've created it great. So we have a couple of ways that we can do things in the ultimate idea of mitigation. And so we look at it in terms of a hot site. A hot site means we have everything, all the components, all the data, everything's ready, it's connected, and in some cases it alternates between the two. So my PSC system is an example of a hot site. So a data center exists at Lincoln that's used for it, and a data center exists at the Med Center. And they're both hot sites. It doesn't matter which one is actually serving up the data, because that data is mirrored between the two of them. Components match, data matches, software matches. So if one of those sites goes down, the other one immediately takes over the load. A warm site is a little lower down. So everything exists, but it may be not installed. We may have to do some updates. We may have to do some installation. We may have to patch some cables over. But everything is there, and most of it's configured. A cold site means, well, I think we have every piece in there, but sometimes our stuff isn't updated. We may have to do some patching. We may have to do software installation. But in terms of cost, it really is that continuum. A cold site's much cheaper. Warm site a little more because I've got more current equipment. And then that hot site is probably the most expensive model. So if that data is critical, if our services are critical, then we look at that idea of a hot site. So we try to calculate which is most effective. And so how important our systems are, how important that data is. And so obviously when we're looking at student information, we know that that's pretty critical for us. We also, depending on the type of incident, we may need to preserve some of that for the law enforcement. We may call in law enforcement first to ask us what to do. So what happened? We had somebody break in and physically steal a server. We probably need to call law enforcement. So you need to protect that data. If you have an intrusion, you may need to protect that data, because the FBI may be very interested. Maybe we lost data at the Med Center. Maybe they also lost data in Maryland and several other places with a similar attack. That might create some benefit for them. So we're really talking about how do we preserve everything we've got? How do we create a network that's resilient and redundant and doesn't go down? I want my employees to be working. I don't want to pay them for sitting around, quite frankly. And now that we've had things like COVID, I've had to extend that out to how do I work from home? And how do I create technology that allow me to access that data safely? And how do I create those redundancies? All right, so this week, let me pull that back real quick. Slide this over. So this week there are 2 simulations. There is a quiz, and then I will put up the video for today as soon as possible. So I have made the final is up and available. I would probably not take it until after next week, but I had a special case need, so I went ahead and made it available. And so we'll talk about that more next week, what the final's going to be. This weekend, I am going to pull all the data to last week. So in other words, chapter 10, everything from chapter 10 is going to pull out of Cengage, and I'm going to upload it, or try to. It's always a fun challenge. Manually update in some cases. So I will be pulling all of those items to try to get us closer to getting ready to get out of here in a week and a half. All right. Whew. That was a lot of talking. Has anybody got any questions? Anybody need a drink of water like I do right now? Got it. All right. So I appreciate it, guys. Have a great weekend, which is always weird to say on a Wednesday to people, but I appreciate it.